There is a particular quality of silence that follows the moment of genuine forgiveness, a quality that is not emptiness, but something closer to the ceasing of a sustained pressure, like a room whose constant low hum you had stopped noticing until it finally stopped. The person who experiences this often struggles to describe it accurately because the vocabulary most people have for inner states is calibrated to movement rather than to stillness, to arrival rather than to the ending of departure. Something that was there is no longer there. A weight that had been carried so long it had ceased to register as weight reveals itself. In its absence, to have been exactly that. What is actually happening in that moment? In the neural tissue, in the immune chemistry, in the intricate circuitry connecting memory to identity to the body's ancient threat response, is considerably more complex than any description of relief or release adequately captures. It involves the coordinated activity of multiple brain systems, the partial rewriting of encoded memories, the chemical modulation of threat detection circuits that have been operating in a state of low-level activation for however long the grievance has persisted, and a reorganization of the predictive model through which the offending person has been categorized and processed. Forgiveness is not the erasure of a record. It is the active revision of one, a biological process with identifiable neural substrates, measurable physiological consequences, and deep evolutionary roots that stretch back far beyond anything recognizable as the moral or spiritual framework through which most cultures have historically understood the act. To approach forgiveness seriously as a subject of neuroscientific inquiry requires first resisting the simplifications that cluster around it from multiple directions. There is the popular spiritual framing, which presents forgiveness as a gift offered to oneself, rather than the offender, a form of release with an almost hydraulic quality, as if resentment were a contained fluid that, once a valve were opened, could simply drain away. There is the pop psychology framing, which collapses forgiveness into a lifestyle recommendation, stripping it of its genuine psychological weight and presenting it as a step toward wellness, alongside adequate hydration and morning exercise. And there is the reactionary dismissal, which treats forgiveness with suspicion as a mechanism of social control or as a demand that victims suppress legitimate responses to genuine harm. None of these framings is adequate to the phenomenon, and none is consistent with what the available evidence reveals about what forgiveness actually is as a psychological and neurological process. The first thing the evidence reveals is that forgiveness is not a single event, but a graduated process, and that the brain regions involved differ depending on which component of that process is active at any given moment. The foundational imaging work examining the neuroscience of forgiveness was conducted by Emiliano Riccardi and his colleagues at the University of Pisa and published in 2013, representing the first systematic attempt to use functional magnetic resonance imaging to map what the brain is doing while a person actually forgives. The experimental design was elegant in its difficulty. Participants were asked to recall real-life situations in which they had been genuinely wronged, situations involving humiliation, betrayal, rejection, or harm, and then, while being scanned, to alternate between states of explicit unforgiveness, in which they were instructed to maintain the perspective of the offense as it stood, and states of active forgiveness, in which they were guided to extend forgiveness to the person who had wronged them. The contrast between these states revealed a consistent pattern of activation that has been substantially replicated and extended in subsequent research. Granting forgiveness was associated with significantly increased activity in a network of brain regions involved in what cognitive neuroscientists call theory of mind, the capacity to represent the mental states of other people, to model what another person might be thinking, feeling, intending, or understanding. The most consistently activated region in this network was the bilateral temporoparietal junction, a structure located at the boundary between the temporal and parietal lobes of the cortex, on both sides of the brain. That has emerged across a large body of research as one of the most important nodes in the neural machinery of social cognition. The temporoparietal junction is activated when people take another person's perspective, when they attribute intentions to the actions they observe, when they distinguish between accidental and deliberate harm, and when they engage in the kind of contextual reasoning about another mind that allows one to move beyond a purely behavioral reading of what happened towards something like an understanding of why it happened. The involvement of the temporoparietal junction in forgiveness is not incidental to the definition of what forgiveness is. It is constitutive of it. What distinguishes genuine forgiveness from mere behavioral compliance? From the performance of forgiveness without the psychological reality of it is precisely the cognitive labor of perspective, taking that the temporoparietal junction subserves. To forgive someone is not to conclude that their action was acceptable. It is to construct, within one's own mind, a representation of the person as a being with a history, a context, a set of conditions that shaped them, a psychological interiority that generated the harmful action, and to allow that representation to alter the motivational relationship to the person. This is an operation of imagination, operating under the constraint of empathy, and it requires the activation of a neural circuit that developed over the course of primate evolution specifically to solve the problem of understanding other minds. The decision to forgive, in other words, requires the brain to use the same cognitive infrastructure it uses to understand any other person, but to deploy it specifically and effortfully in the direction of someone who has activated the threat response, who has been categorized by the amygdala as dangerous or treacherous, and who the emotional brain is actively motivating the rest of the system to avoid, devalue, or punish. This is what makes forgiveness genuinely difficult at the neural level. It is not merely emotionally demanding in the colloquial sense of requiring courage or generosity. It requires the deliberate override of a motivational system that is ancient, efficient, and deeply resistant to voluntary modulation. The amygdala, the almond, shaped bilateral structure in the medial temporal lobe that has become shorthand in popular neuroscience for the brain's threat detector, is involved in the encoding and retrieval of emotionally significant memories, in the detection of social threat, and in the generation of the defensive and retaliatory motivations that constitute the emotional core of unforgiveness. When a betrayal is encoded, it is encoded not merely as information, but as a threat, relevant event whose elements, the person's face, the context, the social category, the quality of the interaction, are flagged with emotional significance and stored in a way that makes them more readily accessible and more motivationally weighted than emotionally neutral memories. The persistence of unforgiveness has a specific neural signature that reflects this encoding. Research examining resting state brain activity in individuals who characterize themselves as low forgivers, people who hold grievances for extended periods and find it difficult to extend forgiveness, has found patterns of functional connectivity that distinguish them from high forgivers in ways consistent with sustained threat system activation. The amygdala in low forgivers shows stronger functional connectivity with the anterior insula, a region involved in the subjective experience of negative emotional states, and with the anterior cingulate cortex in patterns associated with rumination. The self-referential, repetitive, non-productive cycling through negative events and their implications that is one of the most reliable predictors of depression, chronic stress, and elevated inflammatory markers. Rumination is not simply unpleasant. It is biologically costly in ways that have been quantified with considerable precision. Each time a grievance is rehearsed, each time the mental representation of the harm is retrieved and replayed, the memory is subject to the reconsolidation process, the same label re-encoding that makes all retrieved memories susceptible to modification. But in the case of rumination, the retrieved memory is not modified toward anything more benign. It is re-encoded with the full emotional intensity of the current retrieval, an intensity that may itself be amplified by the accumulated activation of previous ruminations. And it is restabilized in a form that may be, if anything, more emotionally weighted than before. The ruminating mind does not process a grievance toward resolution. It rehearses it toward entrenchment, strengthening the associative links between the offender's representation and the threat, relevant neural circuitry that generates defensive motivation and negative affect. The physiological consequences of this sustained activation are not metaphorical. Elevated cortisol, the glucocorticoid stress hormone released by the hypothalamic, pituitary, adrenal axis in response to threat, produces well-documented effects on the immune system, the cardiovascular system, metabolic regulation, and the hippocampus, the structure most critical for the encoding of new memories, and the regulation of the HPA axis itself. Sustained or chronically elevated cortisol is associated with impaired hippocampal neurogenesis, increased inflammatory cytokine production, elevated blood pressure, disrupted sleep architecture, and a range of other physiological changes that translate, across years of sustained unforgiveness, into measurably increased risks of cardiovascular disease, autoimmune dysfunction, and major depression. Research by Worthington and colleagues examining the relationship between forgiveness, stress, and physiological health longitudinally found that greater trait forgiveness, the general tendency to forgive across situations, predicted significantly lower stress reactivity and better self-reported health across a 5-week follow-up period. A separate study examining cortisol responses found that high forgivers showed a greater reduction in cortisol from a stress induction period than low forgivers. A finding that suggests the capacity for forgiveness is associated not merely with lower baseline stress, but with a more efficient recovery from acute stress activation. What is biologically happening when forgiveness actually occurs? When the process crosses from rumination and grievance into something that begins to resolve, is more than the simple cessation of threat system activation. Though it includes that. Research published in January 2026 in the journal Psychological Science by Era Songji Wu and colleagues provided the most direct evidence, yet available, that forgiveness operates through a genuine memory modification process. The study used an encoding and retrieval design in which participants viewed images representing interpersonal harm scenarios and were subsequently guided through either a forgiveness process or a neutral comparison condition. Functional imaging during the forgiveness process showed significant activation in two specific brain regions, the dorsomedial prefrontal cortex and the hippocampus, that was correlated with the subsequent reduction in negativity ratings of the forgiven scenarios. These are precisely the regions implicated in the active updating of emotional memories. The dorsomedial prefrontal cortex in the reappraisal and recontextualization of social information. The hippocampus in the reconsolidation process, through which retrieved memories are re-encoded in modified form. The forgiveness process was not erasing the memory of what had happened. It was metabolically revising the emotional valence with which that memory was stored, embedding new contextual information gathered during the act of forgiveness into the neural representation of the original event. This finding connects the neuroscience of forgiveness directly to the broader science of memory reconsolidation. The process described in research over the past 2 decades, in which the act of retrieving a consolidated memory briefly destabilizes its neural substrate, opening a window during which new information can be incorporated before the memory is restabilized. What the forgiveness process appears to do, in neural terms, is to open this window deliberately and to fill it with specific kinds of information. Information about the offender's perspective, their circumstances, their psychological state, their capacity for remorse, their broader humanity as understood through the cognitive labor of perspective, taking that the temporoparietal junction enables. The memory of the harm is not replaced. The harm remains known. But the emotional color of that knowledge is revised, and critically, the revision persists into subsequent retrieval. The participants in Wu's study showed reduced negativity ratings not only immediately after the forgiveness process, but on the following day when they encountered the same scenarios again. Something about the way the memory was stored had changed. The involvement of the dorsomedial prefrontal cortex in this process is significant beyond its role in memory updating. This region is a central node in the brain's default mode network, the set of structures that are active during self-referential thinking, social cognition, and the mental simulation of other people's perspectives, and it is involved specifically in mentalizing, the spontaneous attribution of mental states to others. The person sitting across from you whose face you know, whose actions you can recall with precision, whose effect on your life you carry, to forgive that person is, at the neural level, to engage the system that constructs other minds, and to use it to build a richer, more contextualized model of the mind that produced the harm. The more complete and complex that constructed model becomes, the more the offender is understood as a person shaped by forces, constraints, and psychologies that genuinely informed their action. The more effectively, the threat categorization that the amygdala applied to them can be revised. This is not to suggest that understanding explains away harm, or that comprehension is the same as absolution. The neuroscience does not support the conflation of forgiveness with condoning. What it supports is the considerably more nuanced claim that the cognitive process of constructing a fuller representation of another person's psychology can alter the motivational relationship to that person, can reduce the chronic activation of the threat response, the compulsive return to the grievance in rumination, the sustained physiological cost of maintaining the offender in the brain's category of unresolved social threat, without requiring that the harm be minimized, that the offense be excused, or that the relationship be restored to its previous form. Forgiveness, as defined and studied in the empirical literature, is an intrapersonal process, a change in the forgiver, that does not necessarily produce any particular outcome in the relationship between forgiver and offender. The relationship can remain ended. The offender can remain absent. The harm can be fully acknowledged in its severity. What changes is not the accounting of what happened, but the emotional weight carried forward from it and the motivational orientation toward the person responsible. The distinction between forgiveness and reconciliation, forgiveness and condoning. Forgiveness and forgetting has been central to the psychological research on forgiveness since Robert Enright began developing the theoretical foundations of forgiveness psychology at the University of Wisconsin in the late 1980s. Enright's process model, refined over more than 3 decades and tested in randomized controlled trials with populations, including abuse survivors, post-conflict communities in Northern Ireland, and adults suffering from depression and anxiety, treats forgiveness as a staged process involving the progressive movement through phases of uncovering the depth of one's injury, making a decision to forgive, working toward a changed affective and cognitive stance toward the offender, and discovering a deepened sense of meaning from the experience of harm and its resolution. This is not a weekend exercise. The model, grounded in clinical application, assumes that the process takes time proportionate to the severity of the harm, and it does not demand outcomes, only movement through a structured engagement with what happened and with the person who did it. Everett Worthington's parallel reach model, an acronym for recall, empathize, altruistic gift, commit, hold, places comparable emphasis on the empathy step as the critical mechanism of change, and the empirical evidence from trials using both models is consistent with this emphasis. What produces change in the measurable psychological and physiological outcomes of forgiveness interventions is not the decision to forgive as such, not the verbal statement or internal resolution, but the quality of engagement with the offender's perspective that the empathy component demands. When participants in forgiveness interventions spend time imagining the offender's history, their vulnerabilities, the conditions under which they came to cause harm, the fear or pain or ignorance or damage that may have animated their action, and when this imagining is allowed to genuinely affect how the offender is seen, the subsequent change, in effect, in rumination frequency, in physiological stress markers, and in the neural representation of the offending memory is significantly greater than when the cognitive component of perspective, taking, is absent or shallow. The neurological basis for this differential outcome lies partly in the relationship between the temporoparietal junction and the amygdala, specifically in the degree to which rich, contextualized social cognition can modulate the threat valuation that the amygdala applies to the representation of a person. The amygdala is not simply a threat detector that operates in isolation from higher cortical input. It receives substantial input from the prefrontal cortex, the anterior cingulate cortex, and the hippocampus, and its responses are shaped by the contextual information. The more nuanced and complete the contextual representation of a person, the more they are understood as a full social agent with a history, a psychology, and a comprehensible set of motivations, the more this prefrontal contextual input can modulate the amygdala's categorization of them as simply threatening. This modulation is what the empathy component of forgiveness interventions is biochemically attempting to produce. The experience of genuine empathy for the person who caused harm, even if that empathy coexists with continued hurt, continued anger, continued grief, shifts the neural representation of that person away from the pure threat category and towards something more complex, more human, and less capable of sustaining the chronic low-level threat response that unforgiveness maintains. The role of oxytocin in this modulation is an area of active and somewhat contested research. Oxytocin, the neuropeptide most commonly associated with social bonding, maternal attachment, and the subjective experience of trust and closeness, has been shown in multiple studies to reduce amygdala reactivity to threatening social stimuli and to increase the propensity for prosocial behavior in contexts of social conflict. A 2025 study from the Salk Institute demonstrated that oxytocin released endogenously in the amygdala sustains prosocial behavior through communication between the amygdala and the anterior cingulate cortex, a region involved in the integration of emotional and cognitive information in social contexts and in the regulation of conflict between competing motivational orientations. The precise role of oxytocin in interpersonal forgiveness has not been definitively established, but the convergence of evidence from social neuroscience suggests that the same neurochemical environment that sustains prosocial orientation, the environment in which extended, empathically engaged interaction with another person becomes possible, is also the environment in which the cognitive labor of forgiveness is most accessible. The chemistry of trust and the chemistry of forgiveness appear to share significant biological infrastructure. This has implications for understanding why forgiveness is so contextually dependent, why it is easier in relationships characterized by warmth and ongoing connection than in those defined primarily by power asymmetry or chronic fear, why it is easier after genuine expressions of remorse than in their absence, and why trauma-informed approaches to forgiveness among survivors of severe harm require particular care in attending to the neurobiological state of the person being asked to engage in the process. The cognitive and emotional architecture that forgiveness requires, the capacity for perspective, taking, the willingness to construct a representation of the offender that exceeds their role as threat, the ability to sustain the effortful neural work of empathy in the presence of genuine hurt, is precisely the architecture that trauma disrupts. Complex trauma tends to produce hypervigilant threat detection, impaired capacity for nuanced social cognition under conditions of threat activation, and autobiographical memories encoded with the heightened emotional intensity of survival-relevant experience. Asking a traumatized person to engage in the cognitive processes of forgiveness without first attending to the neural and physiological state those processes require is asking someone to perform fine motor work while a fire alarm is sounding. The conditions matter as much as the intention. This is not an argument against the possibility of forgiveness in the aftermath of severe harm. It is an argument for understanding what forgiveness actually asks of the brain, and for creating the conditions under which that asking is realistic. The evidence from clinical trials with survivors of childhood abuse, political violence, intimate partner harm, and other severe interpersonal trauma is cautiously positive, structured, forgiveness interventions in these populations. When implemented by trained clinicians who are attentive to pacing and to the distinction between forgiveness and reconciliation, produce measurable reductions in depression, anxiety, and post-traumatic stress symptoms. The mechanism is not one of forgetting, minimizing, or accommodating harm. It is one of gradually revising the neural representation of the person responsible, of allowing the temporoparietal junction to perform its function, at whatever pace the person's system can sustain, of building a richer model of the offender as a human being, and of allowing that richer model to begin the work of reducing the chronic threat system activation that sustains not only psychological suffering, but its measurable biological consequences. The evolutionary context of forgiveness is important for understanding why the human brain has the capacity for this process at all, why the neural machinery for perspective, taking, empathic engagement, and the modulation of threat responses in social contexts developed and was maintained across primate and human evolution, and why it appears to be both biologically possible and, in the appropriate circumstances, biologically motivated. The capacity for forgiveness is not culturally invented, though cultures vary enormously in how they conceptualize, ritualize, and value it. It appears to be part of a suite of social cognitive capacities that evolved in the context of the particular challenges posed by life in small interdependent human groups, where the ability to repair damaged relationships had significant consequences for survival and reproductive success. Research on the evolutionary biology of forgiveness and its relationship to cooperation and punishment has drawn on game, theoretic models, comparative data from primate societies, and ethnographic evidence from human societies across a wide cultural range to reconstruct why the capacity for forgiveness would have been selected. The core finding consistent across these different approaches is that forgiveness is most likely to be extended and to be biologically adaptive in relationships of continuing interdependence, where the costs of permanently severing a relationship outweigh the costs of investing the cognitive and emotional resources that forgiveness requires. Among the Achuar of the Amazon, among the Kungsan of the Kalahari, and among a range of other societies studied by anthropologists, mechanisms for repairing social ruptures, for converting an individual marked as having violated the norms of reciprocal obligation back into a functional social partner, are not merely moral ideals, but practical social technologies that sustain the cooperation on which group survival depends. The psychological capacity for forgiveness, in this reading, is not an achievement of advanced moral reasoning that transcends our biological nature. It is part of our biological nature, a sophisticated social cognitive tool evolved for the management of the relationships that human survival has always depended upon. Self-forgiveness, the direction of the forgiveness process toward oneself as the agent of harm rather than the recipient of it, involves a partially distinct neural architecture that has received considerably less research attention than interpersonal forgiveness. But that is beginning to emerge as a scientifically tractable question in its own right. A 2023 study found that self-forgiveness is associated with greater volume in the fusiform gyrus, a region involved in the recognition and processing of faces and social stimuli, suggesting that the capacity to see oneself as a social being worthy of the empathic engagement extended to others, rather than as a fixed moral category defined by one's worst actions, may have identifiable structural correlates. The psychological process of self-forgiveness appears to require a quality that the psychologist Kristen Neff, whose work on self-compassion at the University of Texas at Austin has been among the most empirically productive in this domain, describes as the recognition of one's own humanity, the understanding that error, harm, doing, moral failure, and the need for repair are not exceptional pathologies, but constitutive features of human experience, shared by all people rather than defining of the specific individual who has done harm. The distinction between guilt and shame is critical here, and it has a functional neural correlate. Guilt, the emotional response that evaluates a specific action as bad, wrong, or harmful, is cognitively distinct from shame, the response that evaluates the self as fundamentally bad or defective on the basis of that action. Guilt tends to motivate repair, restitution, and the desire to make things right because it locates the problem in the behavior rather than in the person, leaving open the possibility of change. Shame tends to motivate concealment, withdrawal, and further harm, doing through the defensive aggression that social threat activates, because it locates the problem in the self, for which no comparable repair is possible. Self-forgiveness, in the empirical literature, is associated with the capacity to metabolize guilt, to take genuine moral responsibility for harm caused without being engulfed by shame, and to allow that accountability to motivate change without sustaining a chronic self-directed threat response, whose biological costs are as real as those of the interpersonal kind. The person who has genuinely forgiven themselves or another carries a memory that has not been erased. The facts of what happened remain available, intact, capable of being recalled. What the forgiveness process has changed is the emotional weight of the retrieval, the motivational orientation that the memory activates, and the chronic physiological burden that the sustained categorization of an unresolved grievance imposed on the body and the brain. The amygdala's threat flag has been, if not removed, then substantially revised. The rumination cycle has been interrupted, and its neural groove, traced by repeated retrieval, has begun to shallow. The cortisol that the sustained activation of unresolved grievance was generating has moderated. The temporoparietal junction has done the work of building a representation rich enough to hold the offender as something more than a source of harm, something more fully human, more fully comprehended, more fully integrated into the social world that the brain navigates rather than bracketed off from it in a perpetual category of threat. This is not serenity. It is not the absence of memory or the dissolution of legitimate judgment about what was done. It is a specific biological state achieved through a specific cognitive and emotional process, one that requires effort, time, and conditions that make the relevant neural machinery accessible. The silence that follows it, the stillness where the hum was, is not emptiness. It is the sound of a system no longer holding open a wound.